Okay, good morning. This is Professor David J. Delos Reyes. Okay, it's Sunday morning already here in Los Angeles, California. Okay, it's August 20, 2023. Okay, my long video format discussion for this morning will be, this morning, it's past 12 a.m. Okay, this should be college algebra, and this will now be lesson number 37. Oh, we are running smooth on college algebra. Okay, I hope you observe some of the concepts I have discussed from the previous lessons prior to this. Okay, let's proceed. Our lesson for this evening will be, or this morning will be, lesson number 37, and this is college algebra. Okay, the title of the topic for this morning will be application problems involving quadratic equations. Okay, I think this is the first time I will be solving a verbal problem on algebra. I don't really concentrate on verbal problems because sometimes the wordings of the problems are too, what do you call this, it's not complicated, but if you are not English oriented, it's hard to understand the so-called wordings of the problem. For me, I'm a Filipino American. I could understand, but sometimes the wording are too complicated. How it was see in English. Okay, so if you are not familiar with the English language, you've got a problem. Okay, but for me, I got no problem. So for this morning, I will now be trying to bring out a problem on applications that involves quadratic equations. Okay, let's proceed. I will give you, since we now know how to solve quadratic equations and the different methods and how to compute for the rows of the quadratic equations, I will now be presenting an application problem, okay, that will come out as an application of a quadratic equation if we try to solve the given verbal problem. Okay, example number 1. Okay, for those who are not so familiar with the English language like some other countries, okay, you will, you got a hard up thing a little bit, but for us in the Philippines, we are English oriented over there. We are already Americanized, that's why maybe our intonation is not so good, but actually what we are seeing, we could write it in paper. Okay, let's proceed. The difference between two whole numbers is 8, and the difference between their reciprocals is 1/6. Find the two numbers. Okay, I will repeat it. The difference between the two whole numbers is 8, and the difference between the reciprocals is 1/6. Find the two numbers. Okay. If you are not English oriented, it's hard to understand this one. But if you are English oriented, okay, you've been like me. I try to, what do you call this, lecture in English. I could speak English, but at least my intonation is not perfect, right? Okay, let's try to bring out the solution. We let x be the bigger whole number. That's my representation of the unknown. And y with the smaller whole number, smaller, because there are two unknowns in the given verbal problem. Okay, the bigger whole number is x, the smaller whole number is y. 1 over x and y over y are actually the reciprocals. So I place it here. 1 over x will be the smaller reciprocal, smaller. Why smaller? Because if x is the bigger whole number, and I will take the reciprocal of that one, okay, 1 over a big number will will be a small number, right? And 1 over y will be the bigger reciprocal. So out of the two reciprocals, 1 over x is the smaller one, and 1 over y is the bigger reciprocal. Because the given condition of the problem is the difference between the reciprocals is 1/6. This is positive. Right? It's positive. So meaning to say, the first number is bigger, okay, than the smaller number for the reciprocals. So bigger reciprocal minus smaller reciprocal, it came out to be equal to 1/6. Okay? So I want to make sure that this is plus, so the bigger reciprocal minus smaller reciprocal will be 1/6. It will not be the other way around, because if the smaller reciprocal minus the bigger reciprocal, supposed to be this is negative 1/6, but it's not negative 1/6, it's positive 1/6. Okay, let's try to bring out the conditions and how we formulate the equations to bring out a quadratic equation later on. Condition number 1. It says from the problem that the difference between two whole numbers is 8. So meaning to say the bigger whole number minus the smaller whole number, okay, should be equal to 8. So x is the bigger number, so x minus y is equal to 8. We call this equation number 1. Okay, we are now formulating our own equation just to solve the given problem. That's algebra. Okay, the fundamental operations is just a part of the solution. But in the formulation of the equation and how to bring out the solution, okay, that's our main problem. So it depends on how you understand the verbal problem. That's why I told you, if we are not, prone or good to the English language, there will be a problem. Okay? Assuming that all my audience are all English speaking, but I think it is not, because if we are exposed to the whole world, of course the variation in the language is different. You know? Okay, second condition. 1 over y minus 1 over x is equal to 1/6. The bigger reciprocal minus the smaller reciprocal is equal to 1/6. I make sure that the first one is the bigger reciprocal. I will be subtracting the smaller reciprocal, okay? And the value is 1/6, and that will be equation number 2. Okay? So actually, we have formulated already an equation involving the unknowns in the problem. Okay? So from equation number 1, if I will try to solve for x, this is now a part of the subject matter we have discussed already from the previous lessons. This is now the solution. So if you didn't learn anything from the previous lessons, okay, there will be a problem here, and I hope there will be no problem. So from equation number 1, x is equal to y plus a. I see it here to equation number 2. Meaning to say the value x equal to y plus 8, we put it on equation number 2. So I will be rewriting equation number 2. The first part is 1 over y minus 1 over x. But x is actually y plus 8. Right? So it seems we are now using this old solution by substitution. Right? So this is 1 over y plus 8. And this should be equal to 1/6. So after the substitution of x equal to y plus 8, what comes out is now an equation involving y only. The question is it a quadratic? Is it linear? We don't know yet, so we must have to simplify first. So we try to simplify the left-hand side while we are combining two fractions with different denominator. So like what the other bloggers are doing in the shorts videos, they're using the butterfly method. So the first part will be 1 times y plus 8, is y plus 8, and 1 times y is just simply y. This is preceded by negative sign, this is minus y. And the overall denominator of the left-hand side is the product of y times y plus 8. So this is y times y plus 8. That's the so-called butterfly method under the short videos, and we are saturated with that one. I hope you are already very good with the butterfly method. Okay, and the right hand side will be equal to 1, 6. This y here cancel with this, right? If we try to expand this one, that will be y squared plus 8y, it goes here, times 1. And since this cancels out, 8 times 6 will be 48. We place it in the right hand side together with the y values. So this should be negative 48 and this should be equal to 0. So actually, the resulting equation after the what you call the simplification came out to be a quadratic equation. That's why the title of the topic for tonight will be Application Problems that Results in the Formulation of Quadratic Equation. Okay? So if there is a quadratic equation, we now know how to solve a quadratic equation. We got 5 solutions, right? Factoring, by taking the square root, by completing squares, by what you call this, using the quadratic formula. And the last one is actually quadratic equation, an equation reducible to what you call this a quadratic equation. Okay, but this is just simply a pure quadratic equation. So the positive solution of this one will be by factoring. The possible factors of y will be y, and the possible factors of negative 48, a plus 12 and a negative 4. Let's try to check the middle term. The middle term should be negative 4y, right? Plus 12y. Combining, minus 4y plus 12y is 8y. So with this combination binomial factors, it came out after the verification that the value of the middle term is 8y. Okay? So the correct binomial factors will be the binomial y minus 4 times y plus 12, and this should be equal to 0. And equating its factor to 0, of course, y1 will be positive 4. Okay? The second value of y will be equal to negative 2. Okay? We disregard this one. Okay? We disregard this one. So by using this equation here, x1 now will be equal to negative y 1 plus 8, or 4 plus 8, and x1 should be equal to 12. Okay? It's easy to check. Using condition number 1, 12 minus 4, right? Is it equal to 8? 8 is equal to 8, right? So it's correct. How about the next one? 1 over y. Y is actually, what's y? 1/4 minus, what is x? 1/12. Is it equal to 1/6? Is it equal? So again, we try to simplify this one, combining two fractions with different denominators. So be 1 times 12 will be 12, 4 times 1 will be minus 4 over 48, right? So what comes out? Is it equal to 1/6? 12 minus 4 is actually 8. So the left hand side is 8 over 48. And is it really equal to 1/6? Is it really equal? This is divisible by 8. This is divisible by 8. So the left hand side is 8 over 8 is 1. 48 over 8 is actually 6. And this is really equal to 6. Okay? So after taking the reciprocals and we subtracted it, what comes out is 1/6 over 1/6. Okay? It is true. So the correct answer for verbal problem number 1 will be x will be equal to 12 and value of y is equal to 4. Okay? That's how we solve verbal problems under algebra. At least we could understand how the problem was worded, if you don't understand how the problem was worded in the formulation of the equation to bring out the unknowns, okay? If you didn't understand, there will be problem. Of course, if you didn't understand the wordings of the problems, your equations will be wrong. So it's a must that we should understand how the problems was worded. Okay, example number 2. A 5 by 7 inch picture is surrounded by a frame of uniform width. The area of the frame and the picture together is 80 square inches. Find the width of the frame. We are given a frame, the shaded area. The dimension of the frame is 5 by 7. And it was mounted, no, picture rather. And this picture is mounted on a frame, okay? It's not, this is the frame, right? This one. The problem is asking what will be the width of the frame if the width of the frame is uniform all around. Meaning to say this thickness here is the same as this thickness, the same as this thickness, the same as this one. So actually there's only one unknown in this problem. It's the thickness of the picture frame. So if we try to designate the dimension of the frame, or the width of the frame, we let x to be equal to width of the frame, right? Then we just go back to our figure. If this is the width, so that will be x, right? This is also the width, that will be x. Considering the vertical portion, this is also x. And this portion here, that's also x. Okay? So the overall length of the frame and picture will be, the overall length, it will be x plus 7. Okay? X plus x is 2x, right? Plus 7. And the overall width will be x plus 5. So that will be 2x plus 5. So we got a 2x plus 5. Am I still on the camera? Okay. That's the right hand side because for any rectangle, okay, if we go to the so-called solid mensuration later on, because again I will be presenting a complete discussion on solid mensuration and what do you call this? For a rectangle, area is actually the product of the length times width. For this total figure here, the total area will be the total length times the total width. Okay? And the problem says that the total area covered by the picture plus the portion of the frame that surrounds the picture is actually 80 square inches. Okay? So actually, by using the formula for a rectangle, we had already formulated the equation on how to compute for the unknown. So to bring out an equation that will compute for the unknown. So 80 will be equal to, we are multiplying to two binomials, right? So it will be the outer part, we use the so-called FOIL method. First outside, inside last. We take the one that's inside, so it's first, multiplied by the second part, right? Then the last portion, as with regards to FOIL, the inside part is actually 7, okay? Again, times the last, okay? That's the so-called FOIL method, or it's just simply in layman's language, it's the so-called distributive law. Okay, I just discussed FOIL in the simplification of this, but the simplification of this is just actually distributive law. So simplifying this one, 80, 4x squared plus the next, plus 14x plus 35. Combining similar terms, 4x squared plus 24x, 80 minus 35 will be negative 45, but this should be negative, okay? Because we transpose this one, it becomes negative, so this will now be negative 45. So after the transposition, what comes out is a quadratic equation. The title of the subject matter for tonight are application problems that resolves to quadratic equation, right? 4x squared plus 24x minus 45 equal to 0. This is now the resulting quadratic equation that involves the unknown. Okay, the unknown width or thickness that goes around. If we try to, I think this is not factorable by inspection. So we'll try to use the so-called discriminant of b squared minus 4ac. The value of a is 4, the value of b is 24, and the value of c is negative 45. If we try to determine what will be the sign of b squared minus 4ac under the radical for the quadratic equation, we will compute b squared minus 4ac, 24 squared minus 4 times this should be negative 45. Sorry for this one. Right? Because if this is bigger and this is minus, there will be a problem. But since the value of c is negative 45, this will become plus. So if we try to simplify this, it's 1296. And 1296 is a perfect square. If we try to take the square root of this, meaning to say the simplification of b squared minus 4ac is the square root of 1296, and that is actually plus 36. Plus or minus 36. So x now, by using the quadratic formula, it should be negative b, the value of b preceded by negative sign, but the value of b is 24, right? So it will just be simply negative 24 plus or minus 36 all over 2 times a. What is a? It's 4. By using the negative sign, that's impossible, right? There is no such thing as a negative x, right? So we will just be using the positive sign. So negative 24 plus 36 will be 12 over 2 times 4, which is 8, and 12 over 8 is actually 1.5 inches. So meaning to say, this width here is actually 1.5 inches. So the answer to the problem is 1.5 inches. We disregard the negative sign. There is no such thing as negative width, right? Okay, that's it, guys. That's how we solve verbal or worded problems under college algebra. I am just telling you, if you are not familiar with the English language, it's hard to understand the verbal problems. So try to learn the English language because it is the #1 language in the world. Okay, for me, I've been English oriented already in the Philippines. Not with the intonation maybe, but at least I could say my English language and I could understand also. Okay, so for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share, okay? Good morning from Los Angeles, Professor David J. De Los Reyes.